Hello everyone, my name is Deepak. I am pursuing BTech Cloud Technology Information Security in Deepak University. I have developed a project naming as a plasma donor application with AWS serverless computing. Let's begin with the project. Before starting with the project, let's understand what is serverless computing. Serverless computing allows you to build and run applications and services without thinking about servers. With serverless computing, your application still runs on servers, but all the server management is done by AWS. Using AWS and its serverless platform, you can build and deploy applications on cost-effective services that provide built-in application availability, flexible scaling capabilities. And this lets you focus on your application code instead of worrying about provisioning, configuring, and managing servers. Then carry forward towards then the main objective of developing of this project is to help COVID-19 patients in finding plasma donors. The Plasma Donor app will reduce the hectic job of finding donors. Being an integrated online system, it will reduce paperwork, removes the communication gap between the plasma donor and acceptors. With serverless computing, there is no need of managing servers, as I told you previously. And as this is a global pandemic, any number of users can register and access. This is the architecture for workflow. Basically, the UI will interact with API gateways through which it will interact with the Lambda functions and backend to the DynamoDB database. All the data is saved on DynamoDB, and through that it will be interlinked towards the methodology and the plan of action. The basically workflow will be the user interacts with the application, register himself as a donor or as a requester. The database will have all the details, and if a user posts a request, then the concerned blood group donor will be notified on his mobile phone by the SMS. This is data flow diagram for the level 0 data flow diagram for this project. User will interact with the three pages: login page, registration page, request page. In login page, authentication check will be done if the user has been registered previously, or else he can register himself as a new user. In the request page, they are the acceptor who wants to accept the plasma. He can request the donor for the particular blood group. And after the login page and registration page, it will be linked towards the statistics page in which the blood count of each blood group is mentioned. Then it comes to detailed data flow diagram. In this, you can understand what are the details, how the process will be done. Uh, then we'll carry forward towards the UML diagram. The UML diagram is the basic model diagram in which it can be when the data is passed towards with each and every services of AWS. When the user uses this is the UML diagram. UML diagram, unified modeling language. Through this, you can understand easily what all the data is passed in the sequential manner, how the data is passed towards the database, and how the database responds towards you. You can understand here. In the first case, there are two chances. If the data is when you are logging in to a page, if your data is found, then you will get a user data found. Data is passed towards the login successful, or else user data not found. Data is passed. Data technical specification. Basically, technical specification software requirement is Python, main Python language for developing the serverless computing. Spider IDE, basically we use Spider IDE because of the Python files are pretty configured over there. Anaconda prompt because all the Flask files and request files are already installed in that. AWS Lambda for building the serverless computing. APIs gateway to pass the request APIs towards the project, and the DynamoDB for saving the database, and some of the packages of Python which will be installed. 3 Flask and request. The hardware requirement is basic processor, RAM, and hard disk. Then carry forward towards the implementation. Now it comes to implementation part. We are here and on the Anaconda prompt. I've given the path for the file where it is saved. Then we'll run the file with python.app.py. This is the Python Flask file in which all the files are being embedded with the APIs link. The server is starting for the local host. We are running the project on localhost right now. The localhost has started. We'll go towards this is our front page with the plasma donor application. Enter the username. Our username is Deepak6. We login. This is the statistic page as you can see over here. We have right now we have 2 O positive donors and 1 A positive donor. From home, we can just we want to request a plasma. If you don't request the plasma, we can just request from here. If you're not A positive, then we submit the request. The donor will be informed by the message on his phone. This is the register page. You can register yourself as a donor over here with the name Entering the name is raju@gmail.com. Session is successful. We can go to home and we can just log in from here. raju@gmail.com, and password is, see, you can see over here, B positive 1, it has been increased. That's all with the implementation, and thank you. Hope you like it.